Hello students, now we are going to evaluate the integral over c e power z by z squared plus 4 dz, where c is positively oriented circle modulus of z minus I equal to 2. The given circle is modulus of z minus I equal to 2. Already we know that this is the center and 2 is the radius. I is center means the point is 0, 1, because I can be written as 0 plus I. So the point is 0, 1. So with this center we have to draw a circle with the point, the radius 2. So let me draw a circle. The point 0, 1. X coordinate 0 means that point will lie on the y-axis. So 0, 1 means this point 0, 1, and from using this as the center we have to draw a circle with radius 2 units. So 2 units means this side up to this, and this side up to this, and this side up to this, and here. So it will be like this. This is the center. No, with that we have to draw. With this as a center. Okay. Now we are, for evaluating this integral, we are going to use Cauchy integral formula. We know that integral over c f of z dz by z minus z naught is equal to 2 pi I into f of z naught when this z naught lies inside c. Otherwise, if it lies outside C, the value will become 0. No need to calculate anything. First, we have to find whether Z0 lies inside or lies outside. Lies outside means the calculation is very easy because the total value will become 0. If it lies inside, the answer is 2 pi I into f of Z0. But we have the formula f of z dz by z minus z0. If it is a linear factor, we can use this one. But the problem given here is a quadratic polynomial in the denominator. First, we have to split this as linear factors using partial fraction. Let me do that. 1 by z squared plus 4. Z squared plus 4 is equal to take this as 0, okay, equal to 0, which implies z squared is equal to minus 4, which implies z squared is equal to, for this minus sign we can take I squared into 4, because already we know that I squared is equal to minus 1. So for minus 1 we can take I squared. So which is equal to I squared into 4 can be written as 2 squared, which is I2 the whole squared. So z squared is equal to 2i. We can rewrite in this way, 2i the whole squared. Z squared is equal to 2i the whole squared. So z is equal to, when we take the square root, we have to take plus or minus 2i. So z is getting two values. One is plus 2i, the other one is minus 2i. So the linear factors are, for this 2i, the linear factor is z minus 2i. For this minus 2i, the linear factor is z minus of minus, that is z plus 2i. So we have splitted z plus 4 as z minus 2i into z plus 2i. So which can be written as, this one can be rewritten as z minus 2i into z plus 2i. Since we have two linear factors, in partial fraction we have to introduce two constants, namely a. So a by 2i plus the other constant is b by z plus 2i, which implies 1 by z squared plus 4 equal to, now we are taking the LCM in the right side. So we have a into z plus 2i plus b into z minus 2i by z minus 2i into z plus 2i. Both the denominators are same, so we can cancel it. After cancellation, we are getting 1 is equal to a into z plus 2i plus b into z minus 2i. For finding a and b values, we have to substitute values for z. From the first factor, if we take z plus 2i as 0, we are getting the value for z as z equal to minus 2i. So we are going to take z equal to minus 2i first. So 1 is equal to, when we substitute here, this term will become 0 plus 2i minus 2i will get cancelled. Finally it is 0 plus b into minus 2i minus 2i. So 1 is equal to minus 4ib, which implies b is equal to minus 1 by 4i. For getting a, we have to take this one as 0. So z minus 2i equal to 0 implies z equal to 2i. So for finding a, we are going to substitute this one. So let z is equal to 2i. So we have 1 is equal to a into 2i plus 2i plus b into, when we take 2i, z as 2i, 2i minus 2i will get cancelled. So b into 0. So which is 1 equal to 4i into a plus 0. So which implies a is equal to 1 by 4i. Therefore 1 by z squared plus 4 equal to a by z minus 2i. So 1 by 4i by z minus 2i plus b by z plus 2i. b is minus 1 by 4i. Minus 1 by 4i by z plus 2i, which can be written as, both the terms are having 1 by 4i constant, so I can take it out. So we have 1 by z minus 2i minus 1 by z plus 2i. So finally we have splitted this quadratic form into linear factors. Now we are going to apply Cauchy integral formula. So the problem given here is, we have to find the integral e power z by z square plus 4 dz. So e power z by z square plus 4 into dz, which is equal to, we have splitted that into two integrations. So 1 by 4i integral e power z by z minus 2i dz minus 1 by 4i e power z by z plus 2i into dz. So let this equation be equation number 1. We are going to find these two integrals separately. First I am going to evaluate, that is I am going to find the integral e power z by z minus 2i into dz. For that, f of z is e power z and my z naught here is 2i. First we have to check whether this 2i lies inside or outside the circle. 2i means the point 0, 2. I'll go to the front. This is the circle, right? So the point now what we have is 0, 2. This is the point 0, 2. Definitely this point is lying inside the circle. So using the formula, this integration, integral e power z by z minus 2i. So this point lies inside C. Therefore this is equal to 2 pi I into f of z naught. So f of z naught is nothing but f of 2i, which is equal to e power 2i. Therefore, this part is equal to 2 pi I into e power 2i. Number 1. The second integral what we have is integral e power z dz by z plus e power z dz by z plus 2i. So here this can be written as, because in our formula we have in the denominator we have the term like z minus z naught, but our term is like z plus 2i. No, so we have to rewrite this as z minus of minus 2i. So now the point what we have is e power z, I will write this z minus of 2i. So here z naught is minus 2i, that is the point here is 0 comma minus 2, right? And f of z is e power z. Now we have to check whether this point 0 comma minus 2 lying inside or outside. This is the point 0 comma minus 1 and this is the point 0 comma minus 2. This point lies outside the circle. So this one lies outside our given C. Therefore, integral e power z dz, integral over C, e power z dz by z plus 2i is nothing but 0. Now we are going to substitute this value and the previous value which we got here now in equation number 1. So this is equal to, therefore, e power z integral over C e power z by z squared plus 4 dz is equal to, the first one is 1 by 4 pi into, the answer what we got here is 2 pi I into e power 2i. So 2 pi I into e power 2i minus 1 by 4i, minus 1 by 4i into the integral value we got as 0. I we can cancel and this one will get cancelled. So finally what we are getting is pi by 2 e power 2i. This is the answer for this integral. The next problem what we have is, we are going to evaluate the integral over C sin pi z squared plus cos pi z squared by z minus 1 into z minus 2 dz, where C is the circle, modulus of z equal to 3. So here the center is 0 and radius is 3. So with 0 comma 0, this point as the center, we have to take 3 units, 1 2 3, and this side 1 2 3 and this side 1 2 3. With this we have to draw a circle. So this is a circle given C, and using that we have to evaluate this integral. For that, first you have to write what is f of z. F of z is equal to sin pi z squared plus cos pi z squared. But in the denominator we are not having a linear factor, it is a product of two linear factors. First we have to split using partial fractions. Okay, so since already we have only factors, no need to factorize it. We have two linear factors, so let me introduce two constants a and b, namely with a by z minus 1 and b by z minus 2. So taking LCM, after cancelling the denominators, we are getting a into z minus 2 plus b into z minus 1. Okay, using these two factors we can decide values for z, that is z equal to 2 as one thing, the z equal to 1 as the second value. When we take z equal to 2, 1 is equal to, this term will become 0, so a into 0 0 plus b into 2 minus 1, it is 1. So 1 is equal to b, that is b is equal to 1. So we got one value. b as 1. For finding a, we have to take the other z value, that is z equal to 1. At that time this term will become 0 and we can find what is a. So for finding a, we have to take z as 1. When we take z as 1, 1 is equal to a into 1 minus 2, it is minus 1, plus b into 1 minus 1, it is 0. So it is minus a equal to 1, so a equal to minus 1. So we got two answers for a and b. A is minus 1 and b is plus 1. We have to substitute here. So we have splitted 1 by z minus 1 into z minus 2 as a as minus 1 by z minus 1, b as 1 by z minus 2. So this can be rewritten as 1 by, I will take the positive term to the front. So 1 by z minus 2 minus 1 by z minus 1. Now come to the problem given. Integral over c sin pi z squared plus cos pi z squared by z minus 1 into z minus 2 dz is equal to, we have splitted this into two integration. Integral over c sin pi z squared plus cos pi z squared by, the first one is z minus 2 into dz minus the second integral is integral over c, the same denominator, sin pi z squared plus cos pi z squared by z minus 1, everything into dz will have come. Okay, so we are going to do these two integrations separately. Let me give the number for this equation as 1. So we have to find here the z0 value in the first one, z0 as 2. Z0 as 2. We have to find whether this value z0 lies inside or outside, and here the z0 is 1. Z0 is 1. So z0 equal to 2 1 value and z0 equal to 1 1 value. Z0 equal to 2 means the point is 2 comma 0. Z0 equal to 1 means the point is 1 comma 0. Here this is 1 comma 0 and this is 2 comma 0. So both the values are lying inside C. Okay, therefore using Cauchy integral formula for the first one, what we have is pi z squared plus cos pi z squared by z minus 2 into dz is equal to 2 pi I into f of z0. F of z0 means f of z0 is equal to, in the first one, z0 is equal to 2. Right. So f of z0 means this is our f of z. So in this, for z we have to substitute 2. So sin pi into 2 squared plus cos pi into 2 squared. So it is sin 4 pi plus cos 4 pi. You know the value for sin 4 pi and cos 4 pi? I'll tell you the general formula. We know that cos n pi is equal to minus 1 power n when n is a positive integer. Sin n pi is equal to 0 when n is a positive integer. For example, if I take n as 1, cos n pi is equal to minus 1 power 1 minus 1. If I take n equal to 3, cos 3 pi is equal to minus 1 power 3, it is minus 1. Cos 5 pi, which is equal to minus 1 power 5, which is minus 1. So we have cos pi, cos 3 pi, cos 5 pi, and all the odd coefficients. No, it will take the value minus 1. If I take n as 2, n as 4, if n as 2 means cos 2 pi is minus 1 power 2, which is 1. Cos 4 pi means minus 1 power 4, it is 1. So cos 2 pi, cos 4 pi, cos 6 pi, we can even include cos 0, cos 0, cos 2 pi, cos 4 pi, cos 6 pi, everything is plus 1. But sin n pi is always 0 when n is an integer, only for integer values. That is sin pi, sin 2 pi, sin 3 pi, sine 4 pi, 4 pi, etc. Everything will take the value 0. But if n is not an integer in this case, for example, if I take n is equal to 1 by 2, sine pi by 2, what is the value for sine pi by 2? It is 1. That's why we are restricting n as a positive integer. Apart from integer, it will take different values. So only for integers, these two will come. Okay, let me go back to the problem. What we have here is f of z0 is equal to sine 4 pi plus cos 4 pi. Sine n pi is always 0. Now only we saw no cos 4 pi, since it is a even number, it will take the value 1, which is equal to 1. So when we substitute here, this one is 2 pi I into 1. So it is 2 pi I in the first case. The first case means when we take the point z0 equal to 2. Now we have to take z0 as 1. This one we have to take. Okay. So here what we have is integral over c sine pi z square plus cos pi z square by z minus 1 into dz. Here z0 is equal to 1. Already we got this one is lying inside c. Okay, so using Cauchy integral formula, this integral is nothing but 2 pi I into f of z0. So here f of z0 is nothing but sine pi 1 square plus cos pi 1 square. So which is equal to sine pi plus cos pi. Sine pi is 0 and cos pi is minus 1. So final answer here is minus 1. Right. Therefore the integral is 2 pi I into minus 1. So which is finally minus 2 pi I. These two answers what we got now. No, one integration is where it is. One integration we got as 2 pi I, and the other one now we got as minus 2 pi I. These two values we are going to substitute in equation number 1. Therefore integral over c sine pi z squared plus cos pi z squared by z minus 1 z minus 2 dz is equal to the first integral value we got as 2 pi I. Okay, so 2 pi I minus the second one we got as minus 2 pi I. So minus of minus plus, so 2 pi I plus 2 pi I, which is 4 pi I. So this is the final answer for the given integral. Is it clear?